I've seen a lot of Docker talks. I was at DockerCon last week, and I think I've seen all the Docker talks. But there's still some little edge cases of things that I have not seen in talks. So I decided to cobble something together to show a lot of the things that, or a few of the things that I have not seen so far. So I entitled this talk Docker Plus Plus. I didn't really write a new Docker. It's just Docker and more stuff. So to get us started, my name is Brian Lyles. I used to be an engineer here at DigitalOcean, and I guess they thought that I was such a good engineer that I moved to the other side of the company. I am now in what we would like to call business development. Not for a lack of technical acumen, but for more of we're a technical company and we want technical people out there looking out for our best interests. But I did want to highlight that we are hiring. We have more than this position. We have some really cool positions like developer advocate. We have front end, back end engineers. But if I were still engineering, I would love to be on internal tools. It's like a new posting. The URL for our career site is do.co/careers. Another interesting thing that we've done is talked about, we're really interested in company culture here in New York. And I'm not from New York, I actually live in Baltimore, but the office is really, and the company is really trying to embrace culture and diversity and the lack of diversity. Unfortunately, we are not winning as an industry, but we are trying as an industry. But we did this little video thing a little while ago, and believe it or not, I am down here on the bottom of the page. They did let me participate, but I think this is good to show that we are a cloud company first, but we are also an education company, and I think that's what separates us from a lot of people. We want to bring you to our platform, but we also want to educate you if you're not using our platform. And if you go search for something Unix related, that's not too esoteric, DigitalOcean will be the first or second choice. But someone put a lot of time into this, so I like to share this link whenever I see it. I'm Brian L. on Twitter. Normally, I like to use DigitalOcean slides, but it wasn't on this laptop, so there's no slides. But I promise I do work here. I tweet from here. And then we have @DigitalOcean too. I forgot to put it on there, but it's fine. Follow us. Follow us to see the artwork that our artists create. If anything else, don't worry about the post. Our illustrators are amazing, and they just do great artwork for all the things that we like to talk about. So let's get into this talk. This talk is, let's say, 3 sections. The first is what is Docker doing? And the second is some cool new things that you may or may not have seen about Docker. And the third one is not even Docker related, but I like to talk about it, so I put it in a slide. So what is Docker doing? Has anyone ever asked? I mean, we go and we boot up our containers, and then we let them run and we let them quit. But do you ever ask your container, what are you doing? So I wanted to actually go into what your containers are doing. And really what I wanted to focus on is how does Docker use cgroups? Anyone here know what cgroups is? Actually, reverse that. Anyone here who doesn't know what cgroups is? All right, it's like half and half. So cgroups are a Linux thing. They're in the kernel. And what they do accounting and let's say limiting. So you can apply cgroups to a process, and it can only use so much CPU or so much memory. It's kind of neat. But it also, what it does accounting. And Docker actually uses this. So let's go on. So let's see what kind of metrics we can get out of cgroups. And this is why I need a C, because I got to type. I promise you here that oh wow, I like my dark color schemes. Hopefully you guys can see this. If you can't, let me know and I'll change it to the boring black on white. Anyone object? Mr. Camera Guy? No. All right, there we go. So let's think about this. Well, before we get into Docker on cgroups, we actually need some Docker containers. Anyone here use Docker Machine? I saw Bora. used boot to Docker. We shouldn't use that anymore. We should use Docker Machine. And the reason we should use Docker Machine is because they took all the good parts of boot to Docker and they made it into an easy to use tool. So I will show you. So we have this binary called Docker Machine. And what Docker Machine does is it allows you to configure one or more Docker environments from your shell. And it's pretty interesting. So the really interesting thing about it is that you can create Docker environments locally. So if you have VirtualBox or VMware Fusion, if you're on the Mac installed, you can do that. But if you can also provision droplets on DigitalOcean or other cloud providers, and it's all built in. And the reason I like to talk about Docker Machine is because the DigitalOcean driver uses the driver that I wrote for DigitalOcean, so I'm actually super proud about that. Another thing that DigitalOcean is trying to do is we have had much success consuming open source, and now what we are trying to do, and this is difficult for a company that has already started to make money, is how do we turn our platform into an open source platform? It's very important for us as members of the community to feel like we are contributing back. So one little thing that we did, and I know this is beneficial for us, is that we are making sure that our API clients are available in all the important languages at least. So your PHP, Python, JavaScript, C#. Believe it or not, C# is the biggest user of our API. I do not know why, but it is. Perl, not Perl. Actually, scratch that. Not Perl. Ruby and Go. So I think that's the ones we're going to do. So I'm sure that pretty much covers everyone in this room. Oh, and Java. Yeah, I'm sorry, Java. And Java is asynchronous and synchronous. So if you're a Scala fan, you can actually take advantage of an asynchronous driver. This is a project that is ongoing. I'm not going to promise you a date, but it's coming. So no Haskell, no Rust, no D. No, whatever language du jour, no, none of that. Only the 7 that I said. So Docker Machine, as I started typing before, has this command in it. But here's the problem I have with Docker Machine. It's DOCKER -MA machine. I don't do that. I actually alias it to DM because DM is much easier to remember, and there's no overlap in common Unix commands. So what I'm going to do now first is I'm going to create a DigitalOcean droplet, and I'm going to use Docker Machine to provision Docker on it. And it's actually pretty simple. So I'm going to go DM create -d DigitalOcean demo 99. And the only reason it's demo 99 is because I probably created other demos. So we don't want anything. So we're going to get an error. And I knew this. This is part of the whole shtick. We have with DigitalOcean, as Borja talked about, we have OAuth, and we have this thing called a personal access token. And I'm not going to go to that page. Actually, I can go to that page because it doesn't show them. So if I go to cloud.digitalocean.com, if it makes me log in, I'm going to close this page. So let's let you know that right now. Yeah, it's going to make me log in. Yep, I'm closing this page. Well, let's just say that I just don't want to type because we do an access token as well, so I didn't want to have to type in my username, my password, and the token. So, but it's okay because what I do personally is I export. I have my access token and my shell, anyways. Oops, let's see. So it needs to be, all right. So what we'll do is we'll go create this and we'll go DigitalOcean access -token and we'll just call it DOPAT because I use this commonly. So what it's doing now is it's going out and it's creating a server, a droplet. From what I remember, by default, it creates, I think in Ubuntu, 512 megabyte droplet. And that's their smallest one. And the cool thing is that to start playing, our smallest product is $5 a month. So to get something up and going, I mean, we're talking like 0.00007 cents a minute. It's not even worth it. worth debating whether you should do this or not. And the cool thing is that a lot of other cloud providers have, it's cheap to get started. And the cool thing about Docker is it's cheap to get started and easy to get started. So what I'm waiting for is giving this a minute to get started. So while this gets started, let's talk about what we're going to do next. So what we're going to look at is CPU, memory, and network stats. And the reason I wanted to bring this up is because I don't see anyone ever talking about CPU, memory, and network stats. And the reason why I know this is because because when I ask people, hey, what's your Docker container doing? They're saying, I don't know. They go do HTOP on machine or something like that. But guess what? It's all there for you. So still waiting for this to be created. Of course, whenever I did this earlier, it was like 30 seconds, but we're still within our minute. So my promise to you is still valid. So still waiting here. So when this gets created, what I'm going to do is I'm going to tell Docker Machine about, I'm going to tell my shell about Docker Machine's environment. And then what I'm going to do is I'm going to take a look around Docker. And it's coming. What'd you say? This is why you went 12 minutes over. But here's the thing. No, I don't need to. If this doesn't come up in 10 seconds, I have a fallback, so don't worry about that. There we go. So now my droplet's up, and here's something cool. This is actually not part of Docker or anything, but at DigitalOcean, I encourage everyone to write open source tools. So I encourage myself to write open source tools. And what I found is that there is just, there is a dearth of command line clients for DigitalOcean. So I wrote one called Dockley. It'll be renamed next week because I found out that everyone who creates a command line client for DigitalOcean calls it Dockley. So I'm renaming mine to Doit, DigitalOcean interactive tool. But Doit is fun. I want to be able to do it. So let's see how this works. So yeah, so we can, what I'm really going to do now is I'm going to go Dockley, droplet, list, and you're going to, DigitalOcean. Everyone spells it differently. I did it like this for my client actually takes a command line. So we'll just go DigitalOcean token. There we go. And what it's going to go out and do is it returns, this version that I have on this particular laptop returns JSON. And here's the last droplet that we created. All it's saying is that it was created at a certain time. Demo99 is the name. It has ½ gig of memory, 1 virtual CPU, 20 gigs of disk. But really what I was looking at was to make sure that it got an IP address. And it did. But you know what? It does not matter if it got an IP address because Docker's taken care of that for you. So one very important thing about Docker Machine, so if I do dm list, dm ls, I have a few of these running. And the one that we have here is the second one, or the third one, Demo99. And you'll notice that the IP that we had before is the IP here. And Docker actually, so what I'm going to do is I want to have this Docker machine, this machine running Docker, be my default Docker. So whenever I type Docker, it does the right thing. So if I do Docker PS right now, it's going to say, I don't know what to talk to you. You can't run Docker on Linux anyway, or on a Mac anyways. So what we'll do is we'll go eval, and we'll run this as a command. So we'll say, I'll do it this way first. dm env demo99. And what it does is it prints out an environment for you. And because this is Unix or a POSIX shell, what you can then do is you can eval it. And what it does is it sets my Docker environment locally to what it needs to be. So whenever I run Docker PS, now I actually have my container. So what's the first thing you do whenever you get a new Docker machine? I know what I do. I go Docker, and I go run, and I give it a name, and I go Redis, or I will call it my Redis. And we'll let it boot in the background, and we'll download Redis. Because you know why everyone downloads Redis? Because Redis, it does something, but it's the easiest program in the world to install, and it's really tiny. So whenever you're doing something that has to have a download, doing a Redis install is pretty cool. So now we have this Docker Redis container here, and now I'm going to go to my notes because I have a good memory, but I do not want to mess this up. So the first thing I want to do is I want to actually verify that this is working. So what I'm going to do is I'm going to run an interactive console with linking. I'm going to run an interactive console linking Redis client with the Redis server so we can talk to the Redis server. So let's do that real quick. Let's see if I have this. Oh, look at that. I already had it in history. So what this is doing, what this command does, is it runs a Redis client, and it links it to the Redis server. And you notice that I'm using the shell. I'm using the environment variables packed from the link container to use it into my new container. So I don't have to know where the Docker container is, and I don't have to know what port. And just to prove that this is working, we can just do some Redis stuff. And that's Redis running. But that's not even what I want to talk about. That's just the setup. This is actually not even part of the talk right here. I could have done this before. But what I want to show you is that for those who are less familiar with Docker, that even things that can seem kind of complex are actually fairly easy sometimes. So let's go into something that's a little more complex. So what I want to do now is I want to get onto my server so I can actually get some stats from this container. And remember, we wanted to look at CPU, memory, and networking. And we'll do that real quick. So what we want to do is go dm ssh to demo 999. It's 9. And now we're on the host. It's real Linux. So if you want to see what it is, so no, it is Ubuntu. I was curious what they gave you. And if you want to see, that is a real machine, half gig of memory here. And now let's explore cgroups. Now cgroups is nice because what it does is it mounts statistics as a file system. And because it mounts it as a file system, you can go look at it. So what we can do is we can go look in our system mounted directory, and we can go to FS, and we can look what's in here. And these are all these cool data sharing things that are mounted under sysff. But we want to look at cgroups. And we can go into cgroups. And if we look in cgroups now, there's even more stuff in here. So we want to look at CPU accounting information. And under here is information for doing things like CPU limiting, memory limiting. But we're not going to do that today. We're just going to go to CPU, turn off our sound. And underneath here, you'll notice there's a directory called Docker. And what Docker, it used to be called LXC, and if you look in their docs, I think they still call it LXC, but it's not, it's actually called Docker now. And you'll notice if we look in this directory, there's things in here, but you'll notice that there's this long SHA-1. And the interesting thing about this long SHA-1 is that we could have found it by actually running docker ps-a with --no-trunk. Hold on, I can't just tell you that, I gotta show you that. Docker PSSA -no-trunk, and you'll see that long SHA-1 is the same as this. So sysfs cgroup CPU. Thought I'd turn this off. Oh, you know what it is? It's this fancy Mac stuff. It's coming through somewhere else, so I guess I can't do that. All right, so if we go into this EBC directory, you'll notice that we have a file in here called CPU acct.stat. And guess what's in there? Anyone want to guess? Yeah, CPU accounting files. And there's only two things in there. There's the user time that the container is taken, and there's a system time. And just to let you know that these numbers are ticks, and I think they're 1/100th of a second, I believe. And so far, this particular container hasn't done much. In the interest of time, I will not move it up more, but trust me that it actually is working. So let's go up and let's have a look at something else. Let's look at memory stats. So, and the same thing with memory. There's another memory directory. If I just went up a directory, and we're looking for a file called memory .stat. And in here is a lot more interesting information. Probably the best thing for you is if you happen to be searching through this file is there's a total RSS, and look at it. It's 991232. So basically, this is in bytes too. So Redis is not taking much memory right now. So basically, it's taking just under a meg, which is kind of neat. That's what we want. We want our containers to be small. We want our containers to be efficient. So why do I show you these things? The reason why is because I encourage everyone to think about monitoring their containers. And because this is a file mounted under cgroups, it means it's a normal file, which means that you can write tools that can parse this, and you can use this for generating your stats. I hope everybody is keeping memory stats for their other apps, so now you can keep memory stats for your individual Docker applications as well. I'm sure the Tudum guys are doing it, right? Yeah, see, look at them, ahead of the curve. So I just wanted to show you that. So let me show you something else. So now let's talk about networking. So Linux, of course, never to keep anything simple, said that no, we're not going to make Linux networking that easy. So you have to do a little bit more work to get networking stats for your particular droplet or for your particular container. And I'm going to show you how involved this is and why we want to write tools. And I definitely wrote this one down because this was kind of crazy. So the first thing we want to do is let's get our Docker SID and our container SID. So that's this long thing is our SID. And the second thing we want to do is we want to we will get out of this directory because we wrote a script. There we go. Was it not big enough? Should I make it bigger? Is that big enough? Is that better? All right. So I actually wrote a script, and I think I just like calling things do it, because that's really what happens. I just want you to do it right now. Just do it. So so we'll run do it, and what the script is doing is, and I'll go through it almost line by line. We have set-e. What does that mean? It means if anything bad happens, bail instantly. I see too many people writing shell scripts that fail, and they don't realize that when a shell script fails, it does not fail. It will just fail in that command, print the error message, and keep on going. So you run set-e, and the script will bomb out wherever it fails. And there's other things you can do for pipe errors, and also, but this is not a talk about that. And then basically what I'm doing is taking the first argument, I'm assigning it to the SID. And then what we're doing is we're going into this SID's device directory, and we're trying to find the PID. And then what we're doing is we're linking it to var run net ns. And what we're doing here is we're relying on this naming feature of Linux, because you can have these containers, and then you have these namespaces. And what we're doing is we're setting up the namespace so that I can run commands within that namespace. So now I can, don't do that. We'll edit that out in post. So what we have now is we ran the script and it set up our namespacing. And now what we can do, since we've done that, is we can now look at, we can run in this namespace, and I think this is it. There we go. And what we've done here is we're running netstat in the namespace of this container. And because we can do that, now we can actually see the transmit and receive just for this particular container. So this is neat whenever you're wondering that, I have 700 megabits running or 700 megabits running out of a server. How much belongs to this particular container? What's the busy container? Before, if you don't set up your namespaces, you can't see it at all. So this is how you would do that. And what I'm going to do for this talk is I'm actually trying out new material on you guys. So I want to make this will probably be a blog post on DigitalOcean or somewhere, and we'll go more into how this is happening. So that is the first part of the talk. So we went over CPU, memory, and networking, and this is pretty neat. But now I'm going to show you something that's a little bit off the wall. So one problem that the Tudum guys really brought up is that Docker's neat, but what happens in production, if you're using volumes, if you're using a volume container and your main container comes up on this server and your volume container comes up on this server. Well, there's a company called Flocker who has created a way to have more persistent containers. And so you can actually so data can be over here, but your container can be over here, but it'll make everything available for you. That solves one problem. And then another problem is that what if you don't know about your network? What if you don't control your network? And what if you, I work at DigitalOcean. Our networking solution, while competent, is not as robust as many other vendors. And while we know we are evaluating some great solutions right now to solve this problem, we recognize the need for people wanting to have somewhat of an overlay network right now. I want to be able to talk to my containers on various hosts without having to know exactly where they are. And I actually might want it to work anywhere. So there are solutions out there. Flannel is one from CoreOS, but I'm not going to talk about that one today. And Weave is another. And Weave is interesting because I think it gets 75% of it gets you 75% of the way there. And the only problem that I have with Weave is that it runs in user land. So because it runs in user land, there's a lot of overhead, and the networking is not as fast. But I challenge a lot of people who say the networking is not as fast to say that you actually needed that network. If you have, in most of our regions, we have 1 gigabyte connectivity out. In a few, we have 40 gigabytes connectivity out. But if in most websites, most people's sites, a gig is actually a lot. Half of a gig is actually a lot. So before we dismiss that as being a failure, let's actually evaluate, measure, and I showed you how to measure now, so we can do that. So let's actually try something else different out here. So what I've done is this is not my code and this is not my demo, but I thought this was so good I wanted to show you guys this in person. So now we have Docker, and we have Flocker. I don't know why they named these things this, and we have Weave. I want to put these all together, but if anyone here configured all three of these tools, I have, and they are a pain in the butt to do, and these guys know that. To build your networks with Docker, Flocker, and Weave, it's a lot of work. There's a lot of moving pieces. And I don't know what's here, and I don't know what's there. But guess what knows what's everywhere? Docker. So what the Docker core team did and made us all happy, and they announced this last week, is they've opened up Docker in a new experimental branch for, they have this feature called plugins. And right now they have networking, volume plugins, and there's one more. The name is escaping me right this second. But they have this concept of plugins. So now vendors like Flocker or Weave can write plugins to Docker, and they actually are connecting to Docker over this API that I will talk about in a second. And instead of having to run all these commands separately, you can hook them in, and they can do everything. They can do almost whatever they need automatically. I want to show you this demo real quick. And like I said before, this is not my demo, and I don't want to take credit for it. But I think it's pretty cool. And I'm running it locally because I want to move it to DigitalOcean, but I think the two of them guys have probably maybe have seen this demo. But it's pretty involved, and I almost got it moved to DigitalOcean, but I have not. So I'm just going to run it locally, and while this boots, it boots two boxes, and while it boots, I'm going to go back to my slides. I went all out for my slides today. This is New York. I thought black and white was trendy here, so we'll stick with this. All right. So Docker plugins. This is neat. So what we're going to do is we're going to build this environment. We're going to use we're going to go all over Docker's ecosystem right now. So we have Docker Compose describing what we're going to build. It's going to talk to Swarm, which is going to boot it on more than one machine. We're going to have two virtual machines. We're going to have one here. We're going to have one here. Each one of these virtual machines is going to run a Flocker plugin, a Weave plugin, a Weave router, and then it's going to actually have our app running inside of it. And the neatest thing about Flocker is it actually uses ZFS. I don't know if you guys have used ZFS, but I'm actually intrigued. And from what I understand now, and it's been confirmed now that it's actually fairly stable because Netflix is using it in production. So if you were scared of ZFS, now is not the time to be scared. But the cool thing here is now that we can put this whole thing together, and now what I'm able to do is I'm able to boot my whole site, have almost zero configuration, and I'll be able to move my site from side to side. And the site is actually really simple. It's actually a Python app that I did not write and a Redis server. The cool thing is that there is actually a load balancer that runs on, let's call this one the main. It runs over here and it balances across, but it doesn't know where anything is. It just knows about Weave IPs. And another cool thing is that Redis can run on both machines, and Redis can fail over to both machines using Flocker. And that's really important whenever you're trying to run databases and containers. As a little side note, I don't know if you really should be running databases. You can run Redis in a container. I say YMMV about Mongo in a container. MySQL in a container or Postgres in a container. Now we're starting to get a little weird. And this is a piece of advice. And I actually verified this with someone from Docker last week. Think about this. Whenever you're running containers, think stateless. Think, I can have one of these, I can have a million of these. And if you can do that, it's cool. But think whenever you have things that are stateful, like databases, think snowflakes. If you put snowflakes in a container, it's gonna melt. And you don't want it to melt. So just think about that. You can, but maybe you shouldn't. So let's see what's going on over here. Look at that. So now, I got good old Vagrant up, and this is just proof that Vagrant did its thing. And now what I'm going to do is I really got to go to my notes from this because this is not my demo, but it's still a pretty cool demo anyways. So I'm going to go. So what I'm going to do is I'm going to let's see. We're going to look in these scripts. So what these scripts do is we're going to create our Weave network, and I'll just go bash-x create network. And what it's doing is it's talking to my master virtual machine and my runner virtual machine, and it's creating a Weave network. And then what I'm going to do is I'm going to do a little bit more configuration on top of that. Scope, we're gonna do this. And now we're assigning some addresses to the network. This is pretty neat. And then what we're doing is we're going to launch our Swarm manager because we're using Swarm, Docker Swarm to manage the network, or manage our applications. So that's that. So now what I'm going to do is I should have done this in a tmux. And the funny thing is I practiced this a few times, and every single time I said next time I should do this in a tmux. But I did not, so now I have to launch a new window. And so let's go here. So we'll go to demo, I think that's the right directory. So the first thing we're going to do is we're going to go into our master machine. And just to prove to you, we're on a virtual machine. It's not my Mac anymore. And we're going to set up our Docker host. And we're going to look at our Docker. And we have Docker running. We have some containers running right now. And the neat thing is that because we set up Weave, and yeah, this is just Weave, basically weaving our network. And the cool thing about Weave is that it runs in a Docker container. So and now what I'm going to do is I'm going to go here to my Vagrant app, and I'm going to bring up my Docker app. And what it's doing is it's creating this web app. And now my app is up. And one last thing I need to do is, because we're only running on 2 machines, I need to have some kind of proxy server so everything knows where to go. So whenever the web requests come in, they can be proxied between the two hosts. So We're going to run this, and now I've created this proxy, and even cooler is that everything in this demo is running inside of Docker. So, so I'm going to go to this host, and I think that's what it is. And this is my web app. And how do we know our web app works? This is what our web app does. You click on it, it makes little Docker things here. And the neat thing about this is that as we create these little Docker things here, the state is actually being stored in Redis. And just to prove that, I'll reload the page, and it's being stored in Redis. So now what we want to do is we want to stop this site, and we want to move it to the other box. So what I want to do here is go to, make sure I'm in the right directory, Vagrant app, and I'm going to go Docker compose stop, and then we're going to kill it, get rid of all the containers, and I'm going to update this thing to move the Redis box to the other host. So pretty simple change here is that I have, in my Docker Compose, I have a web component and I have a Redis component. And notice that we were looking at 172 addresses before, but now these are 1023s. This is Weave. And these are Weave addresses. These addresses could be local or they could be across the world. It does not matter. Weave sets up all the networks for you. So now what I'm doing is I'm changing it to say that Redis now can only run on my other VM. So now we're going to bring up this application again. Dun, 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 dun. Oh, I believe it's up. Nope, it's not up. Still waiting for this application to come up. And this is, all right, hold on, let's see, Docker PS. We'll stop it. I think it came halfway up. So let's see. Let's do up -D. There we go. It actually came up this time. Uh-oh. Oh, there it is. So what happened is I moved my Redis container to another server, and Flocker made sure that the data flocked with it. And now my Redis server is actually running on another host. So what I'm showing here is that Docker has realized how important their tools are to the ecosystem, and they've spent a lot of time in creating these plugins, or creating the system for plugins. So only two more things. So the first thing is that I want to talk about these plugins. Like it or not, right now the plugins are sockets, and what your application needs to do is listen basically as a web server on a socket, and it speaks JSON RPC back and forth. And I think I actually have a picture of what it looks like. So it kind of looks like this. I've been assured that this is a draft, and if it becomes slow or bothersome or cumbersome, that they're going to change it. I have a big feeling that they're going to move it to protocol buffers and sometime in the future. And that's the nerdiest thing I'm going to show you right now. So I want to show you guys one more thing. And the only reason I want to show you this is because our ecosystem has a lot of cool tools right now. And one cool tool is, they're great friends of mine, a group called HashiCorp. Has anyone heard of HashiCorp? They have this tool called Terraform. And what Terraform does is it molds configurations into infrastructure. And I'll show you what I mean by that. So with Terraform, what I've been able to do is I can describe an environment. Oh my God, I showed y'all my token. I gotta revoke that one now. So back to where I was. I don't even know which one that was too. That's even worse. All right, so what I'm doing is I can now, instead of just creating environments, you describe the environment you want to have. And in this particular very, very small case, I'm basically saying here that I have two variables. I have one called my DO token, which I showed you guys earlier, and I have one called my SSH keys. And in another file, I have I can either have my fingerprint of my SSH key, or I can have the ID of something that I've already uploaded to DigitalOcean. And now we have a provider called DigitalOcean that we're going to share our token with. And what I'm going to do here is create a resource. and it's going to be my CoreOS cluster. And inside of my CoreOS cluster, I'm going to have 3 servers running CoreOS beta, whatever version of CoreOS that is right now. And I'm going to change the name because I think there might be a conflict. And they're going to be 4 gig servers in NYC3. And what Terraform will do is it'll actually create this environment. It'll figure out the pieces that are missing, and it'll make it happen. It's kind of synonymous with CloudFormation from Amazon, but the cool part about it is that it's cloud agnostic, and it works with a lot of different things. So if your cloud is hybrid, as a lot of clouds are these days, you can actually build infrastructure over multiple environments. So one thing that I need to do is, because I'm using CoreOS, CoreOS has this service discovery thing. So what I need to do is I need to get a new one. I need to get a token. And why CoreOS does this is when your servers start up. Oh, give me 1 second and I'll tell you why. All right. Curl. Oh, I already have this one here. So I'm waiting for CoreOS to give me a discovery token. If not, I'm just going to make up one and we're going to roll with it. All right. We're going to roll with one. We'll just call it there. You know, how many, I mean, the chance of a collision is very, very small here. So we'll roll with this. So you asked, why is there the count.index? Because inside of the count, inside of the block, there's a count. It knows to do this multiple times. And what it does is, because it's stateful, it'll say the first time it'll be count index 0, and then it'll be 1, and then it'll be 2. And that's
why is it count the same as the count that is like 2 lines above?
Because it's exposed as a variable. That's why. I chalk it up to Terraform has a young syntax. There are a lot of great things, but there's things that do need a lot of work. And this is one of those things that doesn't make a lot of sense. That's what I'm saying. So real quick here, this is what we're going to do. So now, hopefully my internet works. Well, this might be a short demo. My internet is, all right, well, when in doubt, we'll use the guest network. That one seems to work for me all the time. So this is how I know I'm remote. When I bring my laptop to the office, it's just, it doesn't like it here. So now what we're going to do is we're going to go Terraform, plan, and what Terraform will do is it'll actually tell you what it's getting ready to build. And because we're using CoreOS, we use cloud config to actually build it. And now all I need to do is do Terraform apply. And the reason I picked CoreOS is because CoreOS is actually our fastest booting operating system by actually a lot. It should boot this whole thing in less than a minute. But the importance of this is that we want to have repeatable infrastructure. So when we're building our tools, we want to use tools that allow you to build the same thing over and over. And if you happen to build this in staging, you could build this over and over. And tools like Chef, and let's say Chef, we'll try it one more time. Tools like Chef and whatnot, Orca. And Orca will actually take advantage of all the things that I showed you before with the accounting. And you're going to wonder, how in the world does it do this? And could I build this as myself internally because I don't want to use their tool? Yes, you could. You could build this right now. So that's all I have. It's 8:30. It's a good time to go do something else. And I thank you guys. I wasn't kidding. Let's go. No, I'm just kidding. Socialize as long as you want, and I'll answer questions.
Just a quick question. So, next time we do a statement of treat databases like Snowflake, what is the best practice for these sort of data?
Okay, so yes, I put that out there. Treat your database like so. In most cases, if your database is getting any type of usage, I work at a machine at a company that sells virtual machines for money. I'm going to say that in most cases, up to a certain point, we're literally up to a certain point, you can run your databases, your bigger MySQL, your bigger Postgres, your bigger MongoDB on our site. But I will say that at a certain point, and really there's a certain point, this is reality here, you're going to outgrow that and you're going to want your database as close to the metal as possible. And I'll tell you why, because databases were not really made to run in virtual machines. They're not. The way that you tune memory on these things, the way that they want to talk to the disk, they're not made to perform 100% in the virtual machines. But in your cases, and probably almost all the cases, you can run your database in a virtual machine.
So hypothetically, if you're spinning up a simple WordPress and you wanted to make it reliable enough to withstand any attacks, would you be porting multiple instances of WordPress into multiple instances of Dockers and putting your database into a single Docker instance?
If your WordPress is that important, yes, for the first part, but for the second part, you're going to want to have more than one database. You're going to want to have a master, and you're going to want to have at least a slave somewhere for.
They would reside inside of the Docker instance.
You could do that, yes, but would I do it? I don't know. I think the jury's out. I think the community is trying to figure this out right now. And like, I wish I had the best answer. I mean, I talked to a Docker engineer whose job is to work on this, and he's like, I don't have an answer for you. So, give us 6 months, and we'll have another question. Any more questions? Yes, sir.
We have multiple interfaces within a Docker file, network interfaces. We have a Docker image.
So, yeah, actually you can, because guess what? Docker is only a nice abstraction over a few things, notably LXC and C groups and a couple other things. Yeah, actually you can do anything you want inside of a Docker container. You can actually set the IP of your Docker image by yourself. And with Linux, you could create a sub-alias, you could actually create new, because you could do anything you can do with the IP command. So yeah, you could, but don't. Because you know what, the next guy's going to come and he's going to say, who did this? So don't do it.
Well, I mean, like if I want cluster of servers and I want an internal network between those servers.
Oh.
And also public-facing IPs.
So yeah, actually, there is a way to do it. If you look at the Docker, if you do a Google search for Docker Advanced Networking, they give an example that is similar, and they'll show you how to do it. The example they show is how to make two Dockers communicate on specific IPs. So yeah, you can do that. But once again, like I said, you are now going down off the deep end, so be careful. Yes?
What are the benefits of using Weave over just creating a VPN, setting a VPN?
So what are the benefits of using Weave over some other VPN or Open vSwitch or something like that? Ease of use. And one day Weave will solve the running networking and user land story, and it will not be a conversation anymore. I think everyone who's coming out is basically going to come out with the same solution. It's just going to see who gets there first. Even Flannel from CoreOS doesn't solve all the problems, and Weave is still simpler to set up. So I'm only advocating it for you to try it to see what is possible. What I'm saying is that, and I hate to say that another one, this is another place that in 4-6 months, going into the fall, Barcelona, there's going to be another DockerCon in Barcelona in November. I would be willing to wager that a lot of people will have solved that problem by then. Another question in the back? All right. Any more questions? Well, if not, thank you for coming. It was a pleasure. And thank Bora again for his great talk. And I don't know when our next talk is. I actually don't live here. So what is this? It's going to be on a Tuesday. I don't know which one, but hopefully like in a month or so. So please come back. Thank you.